Good morning, everyone. Glad you could join us today. We are going to wait another couple of minutes to give people a chance to get logged in, get set up, get their cup of coffee, get their volume adjusted. We're glad you're taking the time to be with us today. We're excited to present this information. I'll go ahead and go over a couple of logistics. We do have a copy of the slides in the handout section. There are 3 different handouts. One of them is a data sheet for the R8200. One of them is the family brochure. So you're welcome to check those out while we wait. We have a section for chat. If you're having technical difficulties or have a question or have a logistical question, you can post those in the chat. We also have a section for questions. Feel free to post questions during the presentation. We've got a number of people watching those. If somebody can answer those directly, they will. Otherwise, we're going to have a Q&A session at the end. So be saving up your questions, but you don't have to save them up. If you can go ahead and ask at any point. The general structure of our presentation, we'll have a slide that talks about the outline on the first slide or second slide of the presentation. So that's kind of our setup this morning. We're gonna wait just a few more seconds, give a couple more people a chance to get in. And as I get started, we will have a chance for each person who's a panelist to introduce themselves. And we'll let you see what we look like. And then we'll launch into our presentation. Yeah. Okay. Well, good morning, everyone, and thanks again for joining us. We're really glad you decided to spend this hour with us, and we're looking forward to providing you with some meaningful content about PTC ITCR. We've prepared a great presentation for you. We have put a copy of the slides in the handouts, so please avail yourselves of those if you'd like. You will get an email 24 hours after this presentation with a link to the video if you want to refer to it, or if you'd like to pass it on to a colleague, please feel free to do so. Again, we're really glad that you decided to join us today, and we will now proceed to our presentation.
Are you going to introduce your panelists?
So yes, before we launch into the actual presentation, let us introduce ourselves. I'll put my webcam up. There you go, scary face. My name is Chuck Cox. I'm at Freedom Communication Technologies, a Astronics test systems company, and I'm a product marketing engineer. I've spent my career going from the design engineering over into manufacturing engineering, finally over into the sales and marketing side. And it's always my pleasure to visit with customers, potential customers. And all joining us today, we've got Wayne Black. Wayne, introduce yourself.
Well, my name is Wayne Black. I'm Chief Technical Officer for Freedom Communications. I've been a part of radio test for a number of years. I was in satellite communications prior to that. I was in, satellite support, in satellite operations. So I have my whole career has been in communications in different forms and fashions. So today I'll be helping to walk through some of these slides as we discuss our methodology of testing the ITC radio, and I'm glad to be here.
All right, thank you, Wayne. And joining us all the way from the West Coast, Phil. Phil, introduce yourself.
Good morning, everybody. My name is Phil Henning. I work for MeteorCom. We manufacture the radios that the industry uses for PTC. In developing these radios, a lot of the instrument vendors had to also learn about our protocol, and Freedom did as well, and we helped them get this running some years back. I've been in communication in PTC for just a little over 10 years now for PTC, 25 years in the cellular industry, and then before that, I too was in the satellite communication industry, and we utilize the analyzer over here, as you can see. I'm in my classroom here at MeteorCom, so it just lends itself well for this. So welcome, everybody.
All right, thank you, Phil. It's really good to have you with us. We're gonna hide my ugly face now. All right. So we're going to try to keep this fairly interactive. Here, before I actually get started, I'd like to go ahead and launch our first poll, just to kind of get an idea for the makeup of our audience. So in our first poll, let us know whether you are a radio technician, whether you're maybe a supervisor or manager, or an engineer, or other. Other might include some of our channel partners. Always glad to have them with us. You might also be with another test equipment manufacturer. Always glad to have competitors with us on these calls too. Okay, and it looks like we've got about 30% of technicians, which is good, excellent, and some engineers. So guys are really glad to have you with us. Okay, moving on. We're going to talk about, obviously, what the little bit of background. We're not going to spend much time on this, but where PTC came from. And then we're going to look at the specifications that are meaningful to actual PTC itself. We're going to talk about a little bit the modulation scheme of PTC, so you know what you're looking at when you're looking at the test results. We're going to outline how you test these radios, and then we're going to again show you how to set up the equipment to do this. Now, again, as Wayne mentioned, this is not going to be an in-depth training. Phil does have some training classes that he'll talk about a little bit later that they do at MeteorCom. We have a app note that we will make available at the end of the presentation that gives step-by-step instructions. But again, here we just want to give you an overview of what's possible when working with PTC. You're not stuck with just having to work with RF measurements, plain old analog RF measurements. So moving on from there. Okay, so here's kind of a broad outline of where we're headed. We're going to talk about a customer scenario. This is one that Wayne actually brought to me, where our instrument enabled the customer to find a problem that he couldn't find otherwise. We're going to talk about the technical background. We're going to talk about the test methodology. And then finally, we're going to do a live, Phil's going to do a live demo for us from the MeteorCom training room. And so this scenario is this. We had a customer who was testing a base station because it wouldn't communicate. It was communicating, but it was having problems communicating with, it was a base station, and it couldn't communicate properly with locomotives and waysides. They had the RF test equipment. It showed it was putting out full power. They could see the slots were being transmitted, but still couldn't get radios to respond. So then with our Freedom R80-100, which is one of the service monitors in the R8000 series, and the PTC ITCR option, they were able to see that even though there was RF signal there, that the modulation was not correct. And in working with one of Phil's colleagues there at MeteorCom, they determined that in fact there was an actual failure of the hardware that was causing the modulation to be, I don't know if it's scrambled or just not come through clearly. And Wayne, if you've got more about that story you want to tell, you're welcome to, because at this point I'm going to turn it over to you.
Okay. Well, let's go on to the next slide, and we'll go through a few items, and then we'll get to some of the measurements that we can make. So technical background, the PTC system goals, as everybody here involved already knows, this was a PTC itself was mandated in response to certain events that had taken place in the industry, and basically the idea of PTC, which stands for positive train control, means that the positive train control system itself can take action to slow or stop a train without a man in the loop. Prior to this, all of the systems that were utilized for signaling always required, a response either from the engineer or somebody else to be aware that, hey, we've got to slow down at the next turn, or that that there's something, there may even be signal lights telling them to stop. And if they don't see it, or they don't respond to it, or for some reason they're preoccupied, or possibly even incapacitated, impaired, they couldn't do that. So this takes the man out of the loop and will allow the system to either slow it down as needed to let's say take a curve, or come to a complete stop if there's an indication that there's something happening on the line up front. So the main events that this system is designed to prevent, are train-to-train collisions, overspeed derailments, injuries to workers as a result of unauthorized incursions by a train into a work zone, and movement of a train through an improperly aligned switch. And so that was the dictate effectively from Congress to the rail industry. And for the Class 1 railroads, they basically responded by creating the ITC system. So a little bit of terminology, we already discussed. PTC means positive train control. The ITMS system, which is the interoperable electronic train management system. ITCR, which you'll hear us use that term over and over again, that's the interoperable train control radio. So this whole discussion is going to be just about the radios. Obviously, there's a lot more to this system. The radios, though, are the RF connection between the wayside to the locomotive the wayside to the base stations. The radios we're discussing are the MeteorCom PTC 220 or the CalAmp ITC 220. I do understand that CalAmp is no longer producing those radios, but there are many of those radios in the field, and they're identical in terms of functionality to the MeteorCom radios, and they run the MeteorCom software. There are 3 basic radio models that we can test, and we'll be discussing. So you have the base station, which is basically a rack-mounted piece of equipment. It basically sits in the back office area, and it has communications to the locomotive and the wayside. The locomotive radio, of course, is actually on board the rolling stock, and is considered a mobile remote area. And then the wayside radio is considered a static remote area, where those are the smaller radios that are mounted in boxes on the sides of the tracks to provide communications to the moving trains. Okay, let's go on. All right, so physical layer. Frequency band 217.6 to 220 megahertz. Channel bandwidth of 25 kilohertz. The modulation is pi over 4 DQ-PSK or quarter pi DQ-PSK as they're called. And we're going to discuss that just a little bit so that people can have a better understanding of what that really means. Symbol rates are available. They have what they call full rate and half rate. So it's 16 kilosamples per second or 8 kilosamples per second. And I think Phil plans to show you a demonstration of the difference between those two. These are, of course, a TDMA broadcast system, which has the system is designed to be variable in both time slots per second. And the cool thing about TDMA is that's what allows multiple train, so you can have, for example, you may have a wayside, you may be in an area where, like a yard or whatever, and they could have, 12 trains all talking simultaneously. And they appear to be simultaneously, but obviously they're not. They're taking turns, and each one has a scheduled slot, and they can move in and out of those slots as necessary. And so all that's handled, by the executives in the CM control management system. And I'm just going to mention here that the super frame for this is 4 seconds. What that means is that effectively you have a slot 0, and then it runs all the way through, and the whole system starts over again every 4 seconds. So that's where your total slot availability is in that 4 second time frame, and then the system begins again. So quarter pi QPSK. The main difference, there is standard quadrature phase shift keying, which is QPSK. And you can see there on the left-hand side, it's just showing that you have 4 symbol decision points. But one of the things about that, there's two things that can happen in just a standard QPSK. One is you can see as it passes through the center, you basically get a 180-degree phase shift. And going through the center drops the power, to 0, and it comes back out. So there's two complications that they're trying to avoid with using the quarter pi differential, which you can see on the far right. Effectively, every other transmission, it shifts the whole thing by 45 degrees. And so the result is that when you get shifts in phase, instead of getting a max of 180 degrees shift, you only get a max of like 135 degree shift, which makes it easier on the receiver. The other is that it doesn't pass through the 0 point. It bypasses the 0, which allows you to not have to have a perfect linear amplifier. You can have a nonlinear amplifier. So the amplifiers itself for transmission are a little bit simpler, a little bit cheaper. And on the receive side, it's not having to switch from 180 degrees, but only a max, like 135. makes it a lot easier for the receiver. So it simplifies the equipment for both the broadcast and the receive side. So, but what that does do is it creates a little bit of confusion. So if you look, for example, at the constellation display, you appear to see 8 decision points, when in fact there are really only 4. And so you'll see, so when you're looking at like our equipment, if you look at a diagram, the eye diagram, you'll see what appear to be 4 decision points. When you look at the constellation display, you'll appear to see 8 decision points. There are not 8 decision points. What's happening is every other shift, it's basically shifting 45 and back and forth. So there's really only 4, but they're being shifted by 45 degrees and then back by 45 degrees every transmission. So just to make that give that a little bit of understanding, so it makes it a little easier to understand what you're looking at later when you look at the data. So let's go on. Radio timing and operational modes. Because it's a TDMA system, you have to have very precise timing on all of the devices, so they know when to get into their slot, get out of the slot, and you don't end up with collisions. So this is all handled via GPS backbone, where they're using a parts per second, one pulse per second. That's what it is, 1 pulse per second timing. And that way the base station, the locomotive, and the base station, the wayside are triggering off of GPS, and then the locomotive is basically using over-the-air timing coming from the transmissions that it receives, so that everybody stays in proper sync and they all listen at the right slots and they broadcast into the correct slots. So let's go on to the next one. A little bit about the backside and for what we're going to be doing. So in the actual operation, of course, there is a communications manager that is used to configure and feed data to and from the radios, and also to control, what transmits they're on, how much power they put out, what slots they're allowed to transmit into and out of. For our test purposes, we're going to be doing bench tests. So that means we have a single unit connected to our to the 8100, and at the same time, to handle the control of the radio, we'll be using a piece of software referred to as XTerm-W. This is software provided by made available by MeteorCom to whoever has this equipment. It allows it has a little bit of built-in capability in the sense that it's aware that what it's talking to, so it's not just a terminal software. It actually knows the equipment it's talking to. It knows how to set up initialization characteristics and get the unit operational. And then it has some very nice features of being able to create macros of specific sequences of commands. So you can just select the macro and it'll set that whole set of commands in so that you can run the particular tests. And so in this demonstration, we'll be showing that's how we're going to be operating the radio, and then using the test equipment to make the measurements on the RF. So basically, the XTerm-W, it lets you set the transmit receive frequencies. It'll enable the use of a PN9 test pattern, which is a modification of ODOT 153 for bit error rate measurements. It allows to see the forward error correction operation, and then configure the data bits and the slot periods. All right, let's go on. This is a photograph showing just a setup between an R8100 and a wayside radio. You can see that the RF just feeds directly into the radio, and because we can take up to 150 watts of power, so you don't have to necessarily have an amplifier or an attenuator in front of the radio, or between the radio and the unit. And then on the other side, we will have a PC going into the Ethernet maintenance port, and that's what allows us to control that. So from a test hardware point of view, if we're testing, the transmit from the unit under test, whether it's a wayside, a base station, or a locomotive radio, the 8100 will be in monitor mode. You'll set its frequency, you'll set the symbol rate area, and then on the XTerm-W configuration, you'll set up the mode of the radio, you'll set the channel number, you'll set the symbol rate, slot period, and then forward error correction. When you're testing the receive side of the radio, then the 8100 is in generate mode. Again, you set the frequency, you set symbol rate, and then you set our modulation mode to continuous, so that we're creating a modulated signal to hit the radio. On the XTerm-W side, of course, you're setting it to test mode. You set the receive frequency. If it's a locomotive or a base station, you may need to set the antenna and RF receive path. You enable the receiver operation, and then you're able to see the displays of the calculated bit error rate on the external W screen, and we'll see that in a moment. RF measurements that we make all of the RF measurements that were required by MeteorCom to test and make sure to validate the radio's operation. So we have peak and average RF power. We have peak to average ratio, frequency error, vector error, magnitude error, IQ imbalance, phase error, and then of course bit error rate testing. Let's go on.
Okay, this is what it looks like.
And this is what the screen looks like on the R8100. So you can see basically, if you're not familiar with the 8100, just quickly I'll indicate we have 4 zones. We have what we call our RF zone, which in this case is in the top left. We have our display zone, which is where the spectrum analyzer is sitting right now. We have the analog or digital mode zone. And so in this case, when we're in PTC ITCR's mode, that's what you're seeing. And this is where most of your information is going to come from. So we're effectively in monitor. We're receiving a signal. You can see it on the spec. You can see the frequency error in the RF zone. And then in the ITCR zone, you can see your power measurements, your error vector magnitude measurements, your IQ imbalance, phase error, and even bit error rate measurement. And then the last zone is in the bottom corner there. It's what we call our meter zone. In this case, it's showing a constellation display.
So we're not limited to just showing the spectrum analyzer though, right? We've got,
right.
And I've got a couple pictures here. Just got to get switched over. There we go.
The next slide, it shows a couple more examples of a power profile in the display zone or the eye diagram in the display zone.
So in the power profile, this is power over time, right?
Correct.
So this is showing my radio is transmitting in that slot, and then it's stopping and then starting again.
Correct.
And this over here, you were talking about, there's actually 4 decision points. So we see 4 points here, 4 points here, but on the constellation display, we see 8
right.
nodes where the trajectories. Okay.
Right. So yeah. So the eye diagram there is actually showing. So even though between every shift, the physical layer is shifting 45 degrees.
Yeah.
The eye diagram is showing you the decision points that the system is actually making its measure. It's getting its data off of. Yeah. So basically, you've got your 1, your
0, 0,
your 0, yeah,
0, 1, 1, 0, and 1, 1. Yeah. So
and,
basically 2 bits.
So this, 2 bits on each of these points, and that's the data that's coming into the system. And if you take that, so the eye diagram, the distribution plot, and the constellation are all analogous to each other, just looking at it from a different point of view.
Okay.
So the eye diagram, I'm sort of looking down on top of the whole thing. The distribution plot, if I turn it up on the side, and then the constellation is when I turn the distribution to its side, I'm just looking straight down on top of that. And so that spread at the bottom is an indication of how good or how bad the system is operating. And
right.
the eye diagram helps you see that.
So these little white dots would be where the symbols are located over, and this is the carrier frequency and the deviation above and below the carrier frequency. And as the signal gets noisier and noisier, they would spread out. You start to get point clouds instead of dots.
Yeah, and so you can see that in all 3 of those screens.
Mm-hmm. Okay, and then you talked about using the terminal software to get measurements from the radio, and that's what this screen shows.
Correct,
right?
And so that's what this is showing. This is basically a snippet off of the external W interface when we were in the process of looking at a low power level. So we're transmitting lower power into the radio, and we're trying to understand its sensitivity. So the radio itself has given us an estimate of the incoming power level. And then it's showing how many packets were used to calculate the bit error rate. And you can see that the first set, there was about 3 packets in use, and the second set, there were 60. So we must have just kicked the power on when that measurement was made. And then you can see what the bit error rate values are. And so that's the methodology, that's the information that's available to you as you're testing the sensitivity of the receive side of the ITC radio. So.
Okay, and all of this is possible because of a optional functionality in our R8000 series service monitors. Now, that's not just the 8100, although that's what we've been kind of focusing on so far, but this, if you have and use any of these service monitors in your operation for voice or analog work, it's just a software option that can be enabled in the field. You do have to have the minimum firmware version. The firmware is always free, and comes out 4 to 6 times a year. And as long as you've got the latest one or the one required as a minimum for that option, it's just a matter of having someone place a PO. We give you a 16-digit hex key to put in, and within seconds you're able to do this. I just like real quickly to kind of walk you guys through the full family of products as part of the R8000. We started with the R8000, and then we had a B and a C model. These were primarily bench, but they didn't have an internal battery, but you could run them off of an external battery or a vehicle. The 8100 followed that up with an internal lithium-ion battery and a number of improvements that customers had requested. We have a version called the R8600. It's basically an R8000 without a front panel, and it also has 2 large heat sinks and fans, and it can take 150 watts 24/7, so 24 hours a day, 7 days a week, and never overheat. So this is primarily something you would use in an automated factory environment, a manufacturing environment, but there may be other use cases as well. And then just this past fall, we released the R8200. This is taking everything that people have come to love about the R8100, adding a single port VNA. What this means is you can now sweep, instead of having to use an external bridge with the 8100, you can now do all of those measurements directly in the box, and the module that's being used for the VNA is extremely fast, near real time, and so it's a very good tool if you're doing distance default measurements or sweeping filters. It's especially good if you tune duplexers and you want to make sure that your insertion loss is as good as possible. I made a video on this a while back, but anyways, using the vector network analyzer is ideal. And the fact that we've added this to the platform means, and if I'll switch to the next slide here, is now inside of a single instrument, you have all of the functionality you need for testing not only your radios and tuning your duplexers, but sweeping your antennas, sweeping your cables. All of that can be done now without additional equipment. So here, whether you're looking into the transmitter and receiver and making these measurements, whether you're hooked up to the duplexer with the tracking generator or with the VNA, oops, sorry, wrong button, or whether you're actually looking down the line and finding faulty lightning arresters or faults in cables, weather degradation, water ingress, or bad adapters, or as we say here in Texas, when somebody shoots a bullet hole in your hard line, you can tell within inches or even less than an inch the distance to that fault before the tower crew climbs up to look for it. So again, all of that to say, if you're looking for a Swiss Army knife of service monitors, if you do field work and not only radio work but infrastructure work, just this is a very brief plug to say, hey, the 8200 is something you should probably, if you're not aware of it, you should be aware of it. And that's enough pitching. So at this point, what we want to do is we're going to turn this over to Phil. And while I switch this over to make him the presenter, I want to go ahead and launch our second poll. So our second poll is, do you have test equipment with PTC functionality? So obviously the answers would be yes, I do, or no, I don't, or I've got a piece of equipment such as an R8000, but it doesn't have PTC on it. So just real quickly, if you would answer that question for me. Okay, appreciate it. And so now, Phil, if you will, go ahead and unmute yourself if you're not already unmuted. Oh, you're unmuted.
I'm unmuted.
And then go ahead and share your screen.
All right, let me see if I can do this here.
Yeah. Under sharing, yep, under the.
Okay, yeah, sorry about this, folks. This is And the screen that I want is screen number 3, this one. Everybody
Hey.
see my monitor?
We sure can.
Yes, we can.
Okay, sorry for that. It's just a learning curve here. So this is the remote panel that we have, that the unit has, and there's luxuries beyond belief with having such a utility that we can look at this remotely, and of course I can share it with everybody on my computer. And we've talked about, or Wayne talked about, the different areas of the monitor that we can look at, whether it's the PTC ITCR section or the RF section. These are the 2 sections that we're going to be mostly interested in when we do our measurements. And the first thing I'm going to show you is a transmitter being tested. And for anybody that's used other monitors, and especially myself, I have a monitor that I use in here for class, which is a lab grade monitor. You wouldn't carry this out to the field by any means. But in doing so, when I look at the different components of the things that I have to check on my radio, I have to go from screen to screen to screen. And I got to tell you, when I'm teaching a class and I have to do this, inevitably, for me, I forget how to get to a specific place. So I either, tell everybody take a 10-minute break while I figure this out or something. And it's just cumbersome and it's hard. And this has changed. It really was a game changer, because we can see everything on the monitor. Let me get on the one screen. So I'm going to take my radio and I'm going to do a wayside radio, which is the same as what the picture was in the presentation that you guys have seen. So this is a half rate carrier, and a wayside can only transmit in half rate. And I want to preface this with, I have about 4 dB of attenuation between the monitor and the radio. It's just a really super long cable that I had to use, so I've got some attenuation there. And there's a couple of things that we want to see. We want to see, if you look down in the PTC ITCR section, you'll see the peak power and the average power. And those are 2 of the components that we want to look at, and that they are no more than 5 dBm. There's no set, just no more than 5 dBm apart from each other. And of course, looking at this, that passes right away. Our error vector magnitude needs to be 5% or less, and in this case, it looks like it's going between somewhere around 3%, which is fine. The other components that we're really now, of course, we're showing magnitude of error, IQ imbalance, phase error, things like that, and that's all relevant and good. We don't have a spec on what's pass and fail for our customers, but we do have it for our frequency error. And up in the top up here, we can see that the power, the frequency error on this is about -24 hertz, which is a pass as well. All of this on the screen, and you can write all this down. You can just look at this, and you don't have to go anywhere else within your monitor. And if you've got a lot to do, a lot of radios to test, plug this in, turn the carrier up, look at this. You can determine that this radio's transmitter is fine, or identify where there may be a problem with that as well. So what we can also do here, and this is where I always get, I need to go to the ITCR. I need to go to the display mode. And I'm going to show you in real time first of all, here's the eye diagram that we talked about. And you'll see this kind of jittering every so often. There you go. But you'll notice that the points are all clear in the center. So there's your eye diagram. And if I wanted to go and see what the actual constellation looks like, I can select that. And there's that constellation where it's shifting 45 degrees, and then so there's 4 points constantly shifting in 45 degrees. So it looks like there's 8 points, but there's really only 4. And notice what we're looking for here is that the center of this is almost always clear. Oh, it is always clear. So because we're never crossing through that midpoint to end up with 180 degrees of phase shift. So That's the constellation mode. And oops, let's go back to the spec hand. Those are really the things that I wanted to show you with the transmit section on here. And I'm going to go ahead and move. I'm going to turn my. I need to make some real estate on my display here. So I hope everybody can still see this while I move this over. And I'm going to bring over my X-term. We talked about X-term. This is the MeteorCom software, terminal software, that if you own MeteorCom radios or CalAmp radios, either one, doesn't matter, that this software is available to you. You have the right to use this software. So I'm going to go ahead and shut this down. And there's my macros. I've got a series of macros. I'm not going to go into all the details here, but these buttons are the buttons that I'm pushing to make the radio do certain things. I'm going to go into a receiver test now, and I'm going to hover because I can't remember where I put it. There it is, it's under number 5. And I'm going to start this, and I'm going to let this kind of get going, and we're going to see what it looks like. And if you're looking at the presentation that was handed out, you'll see some of these things that should look. I think I did the wrong one. Did I do the wrong one? Yeah, I did. Hang on. Let's do the right one. All right, there we go. Now we've done the right one. So you'll see that right now there's no packets. The very first figure here is that there's no packets because I haven't turned the generator on yet. So I'm going to go ahead over to the instrument now, and I'm going to go to generate, and I will select, oops, did that wrong, generate, and go to, oops, sorry, this is where I'm falling down a little bit on this. So my RF is presently turned on, and you'll see over here that now I am generating and receiving I'm receiving 60 packets every 6 seconds, which that's just a timed thing. Sometimes I'll receive 59, you'll see, sometimes 61. Doesn't line up perfectly. That's okay. That's not what's important. What is important is you'll notice that the bit error rate is 0. What is our signal? Our RSSI, according to this, is neg 113.4 on that, and that is a pass because this is a full rate carrier, and full rate pass fail is neg 108 or lower. In this case, it's a lot lower. So let's go ahead and change that to, let's see here.
The output level will be to press the number 1.
He's just going to switch to the
to the half rate.
So he needs number 4.
Okay.
Number 4, that's what I'm looking for right there. And then here's our symbol rates up here. And I was doing full rate, which is the 16 kilosymbols per second. And then I'm going to go ahead and move it to 8. I'm going to hit the enter key, and I will turn my generator back on again. And now we'll see that first one, I just caught 10. So let's not look at that one. There may have been some errors, or it caught it in the middle of the timing. So now we can see that I'm getting 61 packets and on half rate, and it's about, and you'll notice a neg 112 is my RSSI. Pass fail for a half rate carrier is neg 110. Now, if I was interested in doing this, and I'm not going to do it here because it's fiddling, it takes time, I could reduce my power down to where I just start seeing some errors. And there's my error threshold for that radio. But that's not interesting to me. I got a lot of work to do. I know that at neg 112, this radio passes. Therefore, I'm done with my test, and I can move on to whatever the next thing is. So I'll turn my RF back off again, and I will shut my radio up because it's going to sit there and do that. That should be the last one there. And that's the end of testing the receiver. We've tested both half rate and full rate. They both passed at a lower RSSI level than what my pass and fail is. Therefore, this radio passes, both transmit and receive. And that is all I had. Wayne, did you want me to show them anything else on this, or? Chuck, is that?
No, that's good. I guess we'll wait till the question and answer and see if there's anybody has any specific questions. So Chuck, if you want to go ahead and let's keep moving forward.
Sounds good. I'll take control back. All right. So, and you saw that Phil had some macros created, and we didn't spend time going through all the different commands, but if you're interested in step-by-step instructions, we do have an app note. Typically on these webinars, we'll put a link to the website. This specific app note contains information that really is only intended for railroad radio people. So if you're interested in that app note, just contact us on the last slide that I'll leave up during the Q&A. There'll be some email addresses. You can just email us. And once we verify that you're with the railroad, we'll make that available to you. We do have other information on the website. There's a page specifically about PTC. You see that there. And again, this app note's available.
And I'll jump in just one more time. So I did breeze through this quite a bit. And if there's more detail necessary, MediaCom does provide a class in which I teach, and that is an online class at the moment because of our situation that we're all in right now. And I've done a couple of those, and I have another one coming up here in the next few weeks. I do them about every quarter, and I'll probably be using this instrument to teach the class with, among other ones. I don't stick with just this instrument, but the reason that this one is particularly handy is because I can do this one online and show everybody. The other ones aren't as graceful, so I'll leave it at that.
Okay. Now, Phil, do you have a limited enrollment in those classes, or do people need to?
I do. It is limited to 12 students, and the reason for that is every student has access to and controlling their own radio during the class, and that's our limitation. I have in my classroom that I'm at, I have 12 wayside radios, and I use the base myself, so that's pretty much it.
Okay, and you have some slots available in the next one coming up?
Yes, it's fairly open, and everybody that knows MediaCom knows their account manager. If you don't, I'll be happy to put you in touch with them if that's something that's of interest to anyone out there to attend the next or one of the next online classes.
Excellent. Thank you, Phil. That's I know that could be a valuable tool for some folks. And we understand that that you may not only be supporting the PTC. Some of the PTC technicians are dedicated to PTC, some are not. But I think you will have seen here that you've got a great solution for getting a good picture of what's going on with the PTC. But remember, this is a full featured service monitor that's capable of taking up to 150 watts. And it has, like the RD200 has a VNA, but even if you've got an 8100 or an R8000 with the tracking generator, you can do duplexer tuning. And then, of course, we also have other voice modulation modes available. Just like the PTC, other than the analog, they're optional features. I would like to go ahead and put up our final poll, Tiffany. Just to find out if any of you guys support voice systems. This is you can pick more than one. So if you support analog and NXDN, feel free to pick up both. My understanding is many of the railroads, a large percentage use the NXDN, but we do have some people here supporting DMR and P25 and some Tetra. Tetra is a growing need and a growing opportunity here in the U.S. Okay, excellent. Wonderful. Thanks for that. Okay, and I just wanted to, before we go into full Q&A, I wanted to present a couple of other tools that might be of interest to you. So we've already talked about the various instruments that are part of this R8000 platform. We've talked a little bit about the fact that, firmware upgrades are free. Firmware means that every time you upgrade your instrument, the instrument keeps getting better. We have a lot of cool features, including what we call auto tune. That's the ability to fully automate the testing and aligning of the mobile radios. So let's say you're using Kenwood and XDN radios. We've got auto tune solution where you plug the programming cable of the radio into the instrument, and it will take over and actually tune the radio. I've got a screenshot here and a couple slides that show that. But we've also got a couple of ancillary, what I call ancillary tools that would reside on your PC that allow you to use the instrument in ways that might be of interest to you. For example, on the next slide, we've got something called the Process Automation Toolkit, or PAT. And this basically allows you to create scripts of commands without having to do any programming. We've always provided a what we call M&C, monitor and control, or an API basically, where people could write software to control our instruments, but that limited the people who had that expertise. And so we created this Process Automation Toolkit. It is available on our website if you want to try it out. It's on the upgrades page where you would pick up your firmware. And there's a link to it, and it will download, install, and you can actually connect to the instrument and create scripts. Now, in trial mode, you can't execute a full script. You can run each script step individually. But if you're interested in trying that out and you have our instruments, I'd invite you to go take a look at that. And if you've got questions or want a demo, we've got a webinar and video related to the Process Automation Toolkit, or we can put you in touch with someone who can kind of walk you through it. But that's a really good tool. The other tool is AutoTune. This actually runs on the instrument, and we've got user guides on our website. Again, the links will be on the next slide. This allows you to completely automate and document the testing and aligning of the radios. It has to be written specifically for each radio. So there's a number of radios that we do support, and we can make that list available to you, or you can let us know what you have, and we can tell you whether or not we have an AutoTune. But it truly automates and saves you so much time, because it's a hands-off. You hook everything up, you can walk away, work on something else, and come back and the radio's aligned. It's documented, and you don't have to worry about human error. You don't have to worry about skipping frequencies or tests. It can be run by even a junior tech, or even as we've had in the past, having a front desk clerk running radios through while the technical people are working on problems. So that, I hope, and the only reason I mention these is they might be of value to you. You may not be aware of them. So ask us about AutoTune or the PAT. Here is all the links to the information on our website, such as our product literature, information about our products, a great library of videos and webinars. Some of you mentioned that you support P25 systems. We have a great series that we did on P25. If you're interested in that one, it's not yet linked on there, but just shoot us an email. If you want to find out, well, we have a great support team. Some of them are on this call. If you have support questions, or if you wanted to talk to your sales rep, if you're in the US or if you're international, or distributors, if you have an instrument and want the option, that the information for who to contact is there. Finally, our general email address, freedom.cte@astronics.com. If you want to follow up with us, that's a great email address, because most of us, excuse me, involved in this call get that. And then if you want to specifically ask Wayne a question, there's his email address. Or if you want to tell me to trim my beard, there's my email address. So that being said, now is a great time for us to find out if there's anything else, any questions that we can answer for you. So let me switch over here to my question screen. So I've got one question here that says, what is the overall frequency range? So the PTC itself is in 217 to 222 megahertz, but if you're asking about our instrument, our instrument's capable of 250 kilohertz up to either 1 gigahertz or 3 gigahertz. 1 gigahertz is the default, and then there's an option. Every instrument that we sell is calibrated to 3 gigahertz, but to operate above 1 gigahertz, you do have to have that optional 3 gigahertz option. And then peak modulation gate time is the other part of the question.
Okay, I was just going to say on the DNA, On the 8200.
Oh, that's right.
The single port VNA actually can go up to 6 gigahertz.
That's right. So if you've got an R8200, the VNA itself does have the capability to go up to 6 gigahertz. Now, peak modulation gate time, Phil or Wayne, that's not something I'm familiar with. Is that something we need to research and get back with Marcel separately?
Peak modulation.
Yeah, I'm not familiar with it.
Okay.
I don't have the answer myself. Wayne, is that something?
Yeah, I'm not sure what it, whoever asked that question,
Yeah.
if you could ask a little bit more detail, what is it you're looking for?
Yeah.
If you
Or we can follow up offline. It's up to you if you want to shoot us an email. Or actually, no, I've got your information. So yeah, Marcel will be glad to follow up with you. Okay. Phil, someone is interested in your training schedule, so I will pass their contact information on to you.
Okay, thank you.
Okay, so one question was about auto tune with ICOM. We don't currently have auto tune with the ICOM radios. Not saying that might not happen in the future, but it's not currently on our roadmap. The ICOM radios, since we come out of the public safety sector, that one has not been a high priority, but we are more than willing to work with ICOM.
Well, and they're more than willing to work with us.
us.
They have approached us several times.
Yeah.
So that, you know, it is something that we will do. I just don't know exactly when it's going to happen.
Yeah.
Hopefully within the next year, we're going to be able to do
Start
this.
working with ICOM. Yeah, and the reason we have to work with the manufacturers, they have to give us access to the programming information so that we can communicate with the radio. And there's a lot of legal things that have to go into that, and then there's a lot of technical support that is needed in order for us to take that documentation and get it working. But yes, we're interested in working with every.
We have a good relationship with ICOM,
yeah.
And they are very interested in supporting us. So the problem is not on the ICOM side; it's us getting the resources and to put it together. But that is something that we do plan to do. We just don't have it on a specific time schedule at the moment.
Yeah. Let's see, there was another question about just and this is a great question because on the screen, you can't really tell the size of the instrument. So if you're not familiar with our equipment, it may look bigger to you than it actually is. It weighs, depending on the model.
Yeah, the 8100 with the battery is about 14 pounds. The 8200 is 15 pounds, with the new VNA.
Right. So they're definitely not handheld, but they are the size of a large lunchbox. If you look at our
oversized lunchbox.
Okay.
Maybe.
Well,
Maybe
I guess
for some of us,
I'm a big guy, so I have a big lunchbox. But
I have one right here. Can I share my camera and show it?
Sure, go right ahead. Yeah, I was gonna say we could do that here, but you're probably better set up for it.
So this is the unit right here. So,
and if you want to turn it side to side, just so people can get an idea of the depth, see, it's definitely not a, it's not something that is only comfortable living on a bench. It's something that's often carried out in the field. We also have a glove case that protects it very well. It has a lithium-ion battery, so it'll run off of that. It also comes with a vehicle adapter, DC to DC vehicle adapter. So it is quite comfortable out in the field. I recognize the fact that it's not a handheld unit, but maybe Phil, you could address this is running a full processor. What is your experience in terms of the speed at which it runs versus maybe not naming any, but versus some of the other perhaps handheld solutions?
Sure. There's just never been an issue with the speed of this unit. The R8000 from years back, that's the one I'm most familiar with and use all the time, and it's just never been a problem. And I have had other small units from other manufacturers out there that have a nice suite of capabilities, of features that they do all kinds of really interesting things. But the problem has always been that they're so woefully underpowered. Maybe they're trying to make them do too much. I just don't know. And it makes them very difficult to use because of how much lag there is. And sometimes it's just downright impossible to get it to be fast enough to view what we want it to view. And that's a couple of different vendor products that have been that way.
Mm-hmm. I appreciate that, Phil. And again, we're not trying to put you on the spot or anything. And but that is really one of the benefits of the R8000 series. It's a full-blown computer. It's running off of Pentium class or better processors, and it's not limited in terms of it's not throttled down because of heat dissipation and things like that. It's big enough that it can dissipate the additional processing power. Basically, when and as a field application engineer, which was my previous position here, the things that I kept hearing when I would go visit customers is our instrument's easy to learn, easy to use. It's designed around the way that a technician thinks, and that's what you were saying earlier, Phil. It's all the information I need is right there on the screen. I don't have to jump around, and it's designed to help the technician get his job done. Like you said, you've got a stack of radios you got to get through. You don't get paid to play with test equipment. You get paid to get the job done, and so that's kind of one of the main advantages of the R8000. Again, we're not trying to pitch here, but that's what I keep hearing. That's what people enjoy. If you've never had a chance to use our equipment, I encourage you to reach out to us or our reps who can do a demo, who can bring out a demo, and just do yourself a favor and try it out and see what you think. Okay, so got to move on to a couple other questions before we run out of time. There was a question about how much is the option, and we will follow up with you separately on that, Edwin. But he also asked a question about calibration costs. So that brings up a good question. Our instruments come with a 2-year warranty, parts and labor warranty, but you can also purchase a 3-year and a 5-year service plan, which will get you the calibrations at no cost. They're included for the first 3 or 5 years. So I always encourage people to consider that. If you have an instrument that was purchased with that and you haven't sent it in, you can contact us, service at it's still freedomcte.com, I believe, or reach out to one of us. We'll put you in touch with our service department. The actual calibration cost is, I believe, it's less than $1,000.
It's $675. It's $675.
Yeah. And if it's so that's your normal calibration cost. So if you calculate the cost of the service plan up front, it's less than just the cumulative cost of sending it in every year. But it's very reasonable. Base price for 8200. Ed, do you want to provide that? Or do you want to keep that?
Yes, I will be glad to once I'm unmuted here. The base price of the 8200 is $27,500.
Okay.
And to answer the previous question on the cost of the ITCR option, that's $4,500.
$4,500. Okay.
So an 8200 equipped with the PTC test capability would be 32, if my math is right.
Okay. And again, if you're in a more cost-conscious situation, the R8100 or the R8000 are both capable of running the PTC ITCR option, and obviously there's price breaks on that. Let me see.
And customers may actually already have an older R8000, right? And they can just simply get an update. Maybe you already said that.
They can get it. Yeah, they can get if you've got, as long as you've got the right firmware, which again is just the upgrade. The upgrades are free. You can install the ITCR on your older equipment. Yep. I should mention, since we've kind of gotten off onto this topic, but if you have an old R8000 A model or B model, we do have upgrade plans where you can upgrade that equipment, the hardware on that equipment, up to you know, an R8000C or an RD100 or even an RD200 at much less than purchasing a new one. So again, we've got information we can provide on that. It's just we like to make options available to our customers. Did I miss any questions, guys? Anything that we need to talk about? Marcel, unfortunately, we won't be able to take your question over the air, but we will follow up with you. We've got your email address. As soon as I get off, I'm going to shoot you an email so you have my contact info, and we'll get that conversation going. Appreciate your understanding on that. And we will be glad to talk with you and answer your questions. Okay, any other questions out there before we go? I want to thank everyone for joining us today. If you do have a question, feel free to put it on there. I'll hang around for a few minutes, but I want to go ahead and turn everyone loose if they need to go. It's 12 o'clock. Thank you so much for joining us. When I close the meeting, there will be a survey. It's very short. If you would take just a minute or two to fill that out, or you'll get an email with it. Please fill that out. That helps us a lot understand how we're doing and what other topics we can send your way. So again, thank you so much for joining us, and we hope to see you again, and would love to talk to you if you still have questions or need information. Thanks a lot.